Welcome, everyone, to the second day of ISDC 2019. Actually, the third day, if you count the fantastic space policy forum we had on Wednesday. Did everybody have a good time yesterday? Yeah, thank you. And for those of you that were here yesterday morning, you might recall that I pointed out that the theme of our conference this year is back to the moon to stay. All right? So where are we going? The moon. And what are we going to do? Stay. All right. And I'm excited to say we're going to bring you the man who's going to make that happen. I'd like to say a little bit about administration. You know, you can go to the NASA bio site and, of course, see why he's so qualified to do this. He's a great American. He served his country in both the Navy and in the Air Force Reserve. He's a pilot. He has 3 bachelor degrees in a variety of different things. He has a master's degree in business administration, not from my school, unfortunately, but he knows how to run things, and that's really important. I can tell you from my stay at NASA headquarters during the transition that, you know, technically returning to the moon is not a problem. We did that before, right, 50 years ago. And we've got the smartest people in the world working at NASA and at the NASA centers. We've got the best companies in the world like SpaceX and Boeing and Blue Origin and Lockheed and 1,000 small companies like Relativity Space who can make this happen, all right? That's not the problem. The problem is organization and getting the job done, and it is hard and it is complex. As Mr. Sarangelo mentioned yesterday, the NASA budget during Apollo was 4% of the federal spending, and now it's 0.4%, right? So we're asking this guy to do something with 1/10 the amount of money that we did it before, and we're asking to do it in a permanent way, not just flags and footprints. So this is a really significant organizational and budget challenge, and he needs our support in doing that. One thing about Jim is he's a really nice guy. He is just absolutely a gentleman. And I'd like to show a quick video, I think, that shows just how cool he is. When I drove back from DC to California, my wife and I stopped in Tulsa, Oklahoma, and visited Jim, and he was a member of Congress here. And some of you might know that I support a company that makes skateboards out of carbon fiber scrap from the space industry. I just showed it to him, and he hopped on that thing, right, in his dress shoes. Isn't that amazing? So, you know, you won't meet somebody who is more genuine than Jim Bridenstine. And with that said, I'd like to introduce Jim. If you'd come on up, please.
Thank you, Greg.
Don't worry, we didn't show the end of the skateboarding video. We only showed the good part.
So what Greg's not telling you is at the end there, I actually, we'll just say I fell off the skateboard. And it wasn't pretty, but look, he brings a skateboard. He's like, hey, check this out. This is made out of rocket parts. And I'm like, oh, I'll give it a shot. And I got on there, and sure enough, I fell. But I blame the rain.
The rain, it was absolutely.
Got to blame it on the rain.
And you didn't have the Vans on.
That's right.
All right.
Absolutely.
So, for one last thing, we'd like to offer you 2 quick gifts. One is Space 2.0, a book that National Space Society has published on how to do a lot of great things in space, like return to the moon. And Rod Pyle, the author, is in the audience here. Any of you that haven't ordered your Space 2.0, please do that. And the last thing is we just want to solve your problem with going to the moon because we know the budget's a big problem. So this is something we would like to donate to NASA, which is an extra $50 billion. All right? So that ought to take care of the problem.
$50 billion. All right. 50 billion. That'll do it.
So with that, thank you so very much for coming. We understand your schedule was tight, and he moved the heavens and the earth literally in his schedule to make this happen today. He could have been
I'm supposed to be in New York right now.
Ringing the bell on Wall Street.
Greg called and yelled at me, so I'm here.
All right. Thank you very much, Jim.
Thank you. Greg, I appreciate that very much. It's good to be here. We have a lot going on at NASA. I'll tell you, not too long ago, I had the opportunity, a lot of people in the room remember just a few months ago, China landed on the far side of the moon. And that was the first time that had ever happened in human history. And when they landed on the far side of the moon, you know, it was a lander, maybe about the size of this podium, and it had some good science experiments on it. And of course, the questions I get as the NASA administrator is, how in the world did we fall so far behind? How are we not on the moon? And I get called in to testify before the House and the Senate, and this question keeps coming up. Number one, I want to be clear, landing on the far side of the moon is a really big deal, and I tweeted and I congratulated China on that achievement. That's impressive. It is also true that just a few months before that, and I told this to the House and the Senate, just a few months before that, we landed on the far side of Mars. And we did it, with the InSight lander. It was the 8th time in human history that we've landed on Mars, and the United States of America is the only country that's been able to achieve it. And now when we do these kind of things, we do it with our international partners, which we are very grateful for, and they are helping provide the science experiments and the capabilities so that we could get more knowledge than we would ever get on our own. And they're helping subsidize the program, in essence, so that we can do more science and more discovery and more exploration. But we didn't just land on the far side of Mars with the InSight lander for the 8th time in human history, just in case I didn't say that before. But it's also true that just a few short months after that, we entered orbit around Bennu, which is an asteroid in deep space with a mission called OSIRIS-REx. This is the smallest object that we have ever been able to orbit in the history of humanity. And now we are not just orbiting, but we are characterizing Bennu, and OSIRIS-REx is going to go down and take a piece of Bennu and bring it back to Earth in the year 2021. It will be the first time in human history that we do an asteroid return mission, and that will once again be done by NASA. Just a few short days after that, on January 1st, the New Horizons mission, which of course gave us the beautiful images of Pluto back in 2015, that I've seen all over Capitol Hill in my days when I was in the House of Representatives. Those beautiful images of Pluto, New Horizons went billions of miles past Pluto by a big asteroid in the Kuiper Belt that we call Ultima Thule, and took great images of Ultima Thule, and that mission is still delivering amazing science and discoveries from Ultima Thule. To be clear, Ultima Thule is 4 billion miles from Earth. The furthest object that's ever been studied that close, 4 billion miles from Earth, with a probe that flew by Pluto. And this is a mission, if you look at the return on investment for the dollars we spent, it is absolutely astonishing. A few short months after that, and many people in this room watched as the Crew Dragon attached to the International Space Station, bringing America back again to once again launching American astronauts on American rockets from American soil, which we are going to do this year. So I just want to be clear. We're not falling behind anybody. In fact, we're moving ahead, and we're moving ahead faster. The very first space policy directive of the president said we're going to go back to the moon. But we're going to do it differently than we've ever done it before. This time when we go, as this conference has correctly stated, we're going to stay. The word sustainability is in the program. We're going to go back to the moon sustainably. We're going to go with commercial partners, and we're going to go with international partners. We're going to utilize the resources of the moon. And I know because this is a space audience, everybody here understands the value of the moon. Hundreds of millions of tons of water ice have been discovered on the south pole of the moon. That happened in 2009. From the day that discovery was made up until now, we should have mobilized our entire efforts to get back to the moon. Water ice represents life support. It's not just water to drink, it's air to breathe. But it's also hydrogen and oxygen, which is rocket fuel. It's the same rocket fuel that powered the space shuttles, same rocket fuel that powered the Saturn rocket, same rocket fuel that will power the SLS, the biggest, most powerful rocket ever built in human history, which is underway right now, and we will be launching in the very near term. So we look at these activities that I think are very exciting, and the president gave us budgets that actually are commensurate with the goal, which is fantastic. So NASA's budget, and Greg is absolutely right. 0.4% of federal spending is NASA, less than 1/2 of 1%. Now, I want to be clear, when we go back to the Apollo era and people say, well, we were at 4% of federal spending, that was true. It is also true that back then, federal spending was a lot smaller. The federal government was a lot smaller. So a big chunk of it is just the fact that the government has grown. Another chunk of it is that NASA's budget has shrunk. But in real dollars, if you go back to the 1960s, we did some calculations on this. In real dollars, NASA was spending about $40 billion annually during the Apollo program. That's 2018 dollars. And now, of course, we're at about $21 billion annually. But the President has been upping our budget in his budget requests. Congress has been moving even faster in a bipartisan way to up NASA's budget. There you go. And I will also say that when we got these new budget requests, we started to put together a plan to get back to the moon sustainably with international partners, with commercial partners, and then ultimately utilize the resources of the moon, which is a brand new policy for the United States of America, namely the water ice, and then take that knowledge, information, retire the risk, and go on to Mars. That's all in Space Policy Directive 1, no pressure, but we're going fast to get it done. So here's the thing. You look at all of these activities, and we said, okay, given the budgets that we have, we are confident we can get to the moon in the year 2028. Well, the President and the Vice President looked at that, and as you in this room are aware, the President, when he became President, said, we're going to recreate the National Space Council. We're going to put all of the agencies that touch space, we're going to put the heads of those agencies on the National Space Council, and we're going to make the Vice President the chairman of the National Space Council. So the Secretary of State, the Secretary of Defense, the Secretary of Commerce, the Director of National Intelligence, of course the NASA Administrator, the Secretary of Transportation. We all sit on the National Space Council. We meet maybe once a quarter, and we have discussions about what we want to do in space. So the Vice President gave a speech recently, and we had talked about it ahead of time, and he said, we want to accelerate the program. We don't want to wait 9 years or 10 years to get back to the moon. And the question is why? I get this question a lot. Why don't we want to wait 9 or 10 years to get back to the moon? It's a big deal. I'll tell you why. The reason we're not on the moon right now has nothing to do with technical risk. It has nothing to do with technology. Greg correctly identified the fact that we've been to the moon before. We can do this. Technically, this is doable. The reason we're not on the moon right now is because of the political risk. And in fact, you could argue the reason we're not on Mars right now, 50 years after we landed on the moon, why are we not on Mars? It's because of the political risk. So what we have to do is we have to not just retire the technical risk, we have to retire the political risk. The challenge that we have is that when budgets talk about a 10-year program, budgets change, priorities change, administrations change, Congresses change. So how do we retire the political risk? We go faster. We accelerate the program. The longer it drags out, the more chance there is that we're going to get diverted into something else. So we accelerate the program, and the President and the Vice President said, how much money do you need if we want to accelerate it, and when can you get there? So we said, well, we think we can get there within 5 years, and to make that happen, we gave them a budget request of about $1.6 billion on top of the already very strong budget request that they had given us. And amazingly enough, I made the argument, we don't want to cannibalize the Science Mission Directorate because that'll create a partisan fight. We don't want to go after the International Space Station funding because that'll create a parochial fight with the Texas delegation or the Florida delegation. So we need money that doesn't come from inside NASA. And what they did is they put together an amendment. OMB and the National Space Council and NASA, we put together an amendment. And ultimately, we were able to get a new $1.6 billion in the budget request that doesn't cannibalize NASA. And I'll tell you, friends, that's not the history here. The history is that we do the opposite. We cannibalize one part of the agency to fund another part of the agency, and when we do that, we create partisan fights, partisan divides, and that's the political risk that has prevented us from being on the moon right now. It's the political risk that has prevented us from being on Mars right now. So what we got now is not just a strong NASA budget, but now a plus up in the budget request to return to the moon. And this time, we can actually move forward and make it happen. I will also tell you that when we do these activities, it absolutely must be apolitical and bipartisan. This is an American program, and it's in fact an American program where we're going to lead international partners. And this program ultimately needs to be sustainable for the long term. It needs to span multiple administrations. This is something where I want my 11-year-old daughter to be able to see herself and say, I want to be part of that program. 20 years from now, I want to be the one on the moon. That's the goal behind this program. That's why the word sustainable is in Space Policy Directive 1. We're trying to inspire and motivate that next generation. So we talk about how do we go to the moon sustainably? Well, number one, the $1.6 billion new dollars is going to be focused on a couple of things that I think are important. Number one, we've got to get the Gateway built. The Gateway, think of it as a very small space station. Some people say, well, it's not a space station. Well, it enables human access to the surface of the moon. And over time, with international partners, it actually has an opportunity to grow, to do science of the moon, science of deep space, do science in the microgravity environment on the Gateway. All of these capabilities exist resident at the Gateway with international partners. But by 2024, this 5-year plan to get to the surface of the moon, the Gateway will have 2 elements. One is a power and propulsion element, and 2 is a mini habitation module. The power and propulsion element is critical. Here's why. When we went to the moon, again, we're not going back to the moon, we're going forward to the moon. We're doing it in a way that's never been done before. This time when we go to the moon, we're going to stay. But we don't just want to stay. We want to have more access to more parts of the moon than ever before. During the Apollo era, we landed at the equatorial regions of the moon because that's where we could get to. We landed 6 times within 3 years, and each of those times we got a lot of knowledge and information about those very specific points where we landed. Well, the Gateway is going to be in orbit around the moon with solar electric propulsion, and it's going to be there for 15 years. That means we're going to have more access to more parts of the moon than ever before. In other words, we're not going to miss. Here's this. We missed the fact that there was water ice on the south pole of the moon, hundreds of millions of tons. We missed that for almost 40 years. From 1969 until 2009, most people believed that the moon was bone dry. Then we make these discoveries. All of a sudden, we know that there's hundreds of millions of tons of water ice. Question is this. What else have we missed? The Gateway is about giving us more access to more parts of the moon than ever before. That means not just with humans, although humans are a critical piece of it, but also with landers and rovers and robots, so that we can get more knowledge and more information about the moon than ever before. People say, well, what else do you want to know about the moon? The moon is a repository of some of the most important scientific data in our solar system. We think about the Earth. We're protected by this magnetosphere. We have a very active geology. We have a very active hydrosphere. We have a very active atmosphere. The moon doesn't have any of that. Whatever impacted the Earth 2 billion years ago is not today where it was 2 billion years ago. And in fact, it might not have hit the Earth at all because of the magnetosphere itself when we talk about charged subatomic particles. Well, the moon is a repository of billions of years of history. Whatever impacted the moon billions of years ago, whether it was an asteroid or a subatomic particle, it is today right where it was 2 billion years ago. So I think it's important that we go back to the moon now with a new ability to do science, new ability to do discovery. We go there with humans, but we also go with landers, rovers, and robots, and we're able to command and control numerous missions on the surface of the moon, all happening at the same time from this orbital habitat we call Gateway. The solar electric propulsion, the maneuverability capability of Gateway is critical. So we want to use the Gateway. That's going to help us get to the surface of the moon. We need to get that underway. We announced just a few weeks ago that Maxar is building the power and propulsion element. We were able to accelerate that significantly because of this new date. Some people who are in this room know how NASA works. And things get reviewed and reviewed and reviewed, and when one center makes a decision, the other centers question what that decision was. Hundreds, if not thousands, of questions, reversals of decisions, and then we start over again and go back to the drawing board, and we do a lot of analysis. When the vice president said that we're going to accelerate the path to the moon, that we're going to do it within 5 years, he said, do not get bogged down by paralysis by analysis. And that's what we're not doing. So instead of having all of the centers review and then second guess and take it, we actually went forward. We said, okay, the Glenn Research Center made a good call. We're going forward with this selection. We made it happen faster than it otherwise would have happened because we have this new date. It's a new era at NASA. We're going fast. So the power and propulsion element is now under contract. It's moving forward. We're going to do a mini habitation module on the gateway. And then the next big thing that we need is we need to aggregate at the gateway between now and 2024. We need to aggregate at the gateway a lander capable of taking our first humans to the surface of the moon. And I want to be really clear about this lander and what this program is all about. 50 years ago, we went to the moon under a program called Apollo. It just so happens that Apollo, in Greek mythology, has a twin sister named Artemis. Artemis also happens to be the goddess of the moon. This time when we go to the moon, we have a very diverse, highly qualified, and very talented astronaut corps. And under the Artemis program, named after the twin sister of Apollo, for the first time in human history, we are going to have an opportunity to send women to the moon. When we think back to the 1960s, all of our astronauts came from fighter pilot, background or test pilot background, and there were zero opportunities for women. I really believe, with all of my heart, I have an 11-year-old daughter. I've said it before. I'm going to keep saying it. I want her to be able to see herself as having every opportunity that I saw myself as having when I grew up. And I think that's one of the reasons the Artemis program is critically important. So we need to get these landers built. We're going to do the landers in a way that NASA is not used to doing things. We're going to buy the service. We know we are going to have astronauts on the gateway. We need to get those astronauts to the surface of the moon. We are not going to purchase, own, and operate the landers in the traditional sense, where we write thousands and thousands of requirements, basically design everything through the requirements process. Then we put out requests for information. We put out requests for proposal. We get proposals over the course of a year. Then those proposals come in. We spend a lot of time doing a selection process. After that selection process is complete, we make a selection, and then we spend a bunch of time with protests. We're not doing that. What we're doing is we're going to buy a service. We're going to say to a company, who can get our astronauts to the surface of the moon, prove to us that you can do it, and we're going to buy it as a service. We're not going to purchase, own, and operate the lander. We're going to buy the service. And by the way, we're expecting that you're going to put your own skin in the game because you're going to have customers that are not NASA. That's what we're trying to achieve here with this new lander program. And that's going to help us go faster than we could otherwise go. So that gets us to the surface. Yeah. So that gets us to the surface of the moon. So what we're doing is we're building the architecture that is sustainable. It will have international partners. As I just identified, it will have commercial partners. We're going to go to the parts of the moon. The vice president was very clear. In 2024, he said, the next man and the first woman on the moon will be Americans, and they will be on the South Pole of the moon. That is very clear. We have never been to the South Pole before. This time we're going to the South Pole. Why? Because that's where the water ice is. What else is there? I don't know. Some people have talked about platinum group metals. We know we have these rare earth metals here on Earth. We also know that rare earth metals are not earth metals at all. They're asteroid impacts from billions of years ago. The challenge is here on Earth, they end up being very rare because we have this active geology and this active hydrosphere and atmosphere. So that it's really hard to find them today, and when you find them, they're in trace amounts. Well, here's the thing about the Earth and the moon. We're always together. We're always flying through the same space together. So any asteroids that hit the Earth, chances are that same asteroid field also hit the moon. Is it possible that there's potentially billions of dollars worth of platinum group metals on the moon? I don't know, but I think we ought to find out. And I also think that that there's a lot more that we can learn. It's not just the science, it's also the resources, the water ice, maybe platinum group metals, maybe other things. Who knows? Here's the thing. We don't know. We need to go find out. And when we prove this capability and we retire the risk, we're talking about being able to have access to any part of the moon anytime we want in this sustainable architecture. We also want to take all of that capability and make it replicable so that we can take that architecture onto Mars. That's another reason why the gateway is so important. While this is about the moon, it's about something even more, which is Mars. Here's what we know about Mars. The Earth and Mars are on the same side of the sun once every 26 months. That means when you go to Mars, you got to be willing to stay for long periods of time. The glory of the moon is that it's a proving ground. It's a 3-day journey home. If something goes wrong, we know that we can make it back. We proved that on Apollo 13. If something like Apollo 13 were to happen on the way to Mars, it would be over. The moon is the proving ground. We have an opportunity to learn how to live and work on another world for long periods of time. Take all of that capability, take all of that learning, and apply it to Mars. The moon is the way to Mars. Some people say, well, every dollar you spend going to the moon is a dollar you don't spend going to Mars. Fundamentally untrue. If somebody tells you you're going to go to... If somebody tells you you're going to go to Mars for the first time without going to the moon, they're kidding themselves and they're lying to you. It cannot be done. The moon is the proving ground, and it would be extremely irresponsible to do it with a Mars mission without using the moon to learn how to live and work for long periods of time. So we need to understand that we go to the moon so that we can go to Mars. In fact, there have been a number of reports written that indicate that the quickest way to Mars is to use the moon as a proving ground. So the question is then, why do we go to Mars? You guys are familiar with Spirit and Opportunity. These little robots. 2 of the 8 times we landed on Mars. Spirit and Opportunity have given us some really magnificent information. We know that Mars had an ocean in its northern hemisphere. 2/3 of the northern hemisphere of Mars was covered in ocean. We know that Mars had a strong magnetosphere that protected it from the radiation of deep space. We know that Mars had a thick atmosphere. In other words, at one point in history, Mars was habitable. I'm not saying it was inhabited. I'm saying it was habitable. Sometime 3 billion years ago, all of that changed. What changed? Did the molten core cool? And therefore it lost its magnetosphere? It loses its magnetosphere? It loses its ocean and its atmosphere? Maybe, we don't know. That's why we have InSight on Mars right now, trying to make the investigations on the interior of Mars so we can learn more about the history. By the way, by studying Mars, we can learn a lot about our own planet. Because if Mars was at one time like Earth, what will Earth be billions of years from today? It's a concern. It's of interest. I'm not going to be around billions of years, but we ought to make these discoveries and make these assessments. A couple of other things that are important on Mars. I've been the NASA administrator now for a year and a couple of months. In this amount of time, we have discovered some amazing things. Number 1, complex organic compounds exist on the surface of Mars. Those are the building blocks for life on Mars. They're not on the moon. Nothing at all on the moon from complex organic compounds, but they're on Mars. The building blocks for life are on Mars. We also discovered that the methane cycles are commensurate with the seasons of Mars. Does that guarantee life? No, but the probability just went up. We also now know, in the last year, that there is liquid water 12 kilometers under the surface of Mars. This is a brand new discovery. Liquid water, 12 kilometers under the surface of Mars. What do we know about liquid water on Earth? Everywhere it exists, there's life. And I'm not saying that there's life on Mars. I don't know, but we ought to find out. And we ought to send humans there. And to do that, we need to go to the moon. We need to establish all of the technologies and capabilities so that we can go to Mars, so that we can learn how to live and work on another world, so we can make these discoveries, learn more about our solar system than ever before. I'm going to stop talking here in a few minutes, and I'll open it up to some questions. But know this. I'm the first administrator in history that has, everybody, you walk around NASA, everybody has that moment in time. They know exactly where they were when Neil Armstrong and Buzz Aldrin stepped foot on the moon. I see a bunch of people nodding their heads. I don't have that memory. I wasn't around back then. And there's a lot of us in this room that we weren't around back then. The Apollo generation was not our generation. We love it. It changed history. It changed the direction of the world. We love the Apollo generation, but we weren't there. This is our generation. This is our time. We have opportunities to do things today that we couldn't have done in the 1960s and 1970s. So know this, we are the Artemis generation. We need to be communicating about the Artemis generation. This time when we go to the moon, we're going to go sustainably. Another big difference between now and 1969, this time when we go to the moon, we're going to go with commercial partners. We're going to go with international partners. There's more international partners now in the world than ever before in human history, and they all want to go to the moon. The United States of America sent 12 men to the moon from 1969 to 1972. We're the only country that's ever done it. Other countries want their shot. And friends, we can partner with them to achieve more on the moon than ever before. So the Artemis generation is who we are. This is what we need to be communicating on. That this time when we go to the moon, it's very different. We're going forward to the moon. We're not going back to the moon, we're going forward to the moon. This time we're going to stay. A sustainable program that's going to have the ability to use our very diverse, very talented astronaut corps and send the first woman to the surface of the moon. So with that, thank you for having me. It's great to be here, and Greg, I'll open it up to a few questions. Is that all right? Yes, please. Okay. And should I just make the calls, or should I have somebody else make the call? Okay.
Yes.
Say that again? Oh, yeah, I've got a video. Can you hold your question?
Okay.
All right. You'll be the first one out of the gate after this video. So we're going to play this video. It kind of describes how we're going to build this architecture to get to the moon and what we're going to do when we get there. You're going to see a lot about SLS and Orion, the gateway. You're going to see about commercial landers. You're going to learn about what we call CLIPS. One of my first initiatives when I got to NASA was we're going to buy access to the moon. We're not going to purchase, own, and operate hardware, but we're going to buy access to the moon for small science payloads. And now we have 3 companies under contract to deliver small science payloads for NASA by as early as next year. So we're going to learn about that in this video.
50 years ago, we pioneered a path to the moon. The trail we blazed cut through the fictions of science and showed us all what was possible.
It's very pretty out here.
Today, our calling to explore is even greater. To go farther, we must be able to sustain missions of greater distance and duration. We must use the resources we find at our destinations. We must overcome radiation, isolation, gravity, and extreme environments like never before. These are the challenges we face to push the bounds of humanity. We're going to the moon to stay by 2024, and this is how.
This all starts with the ability to get larger, heavier payloads off-planet and beyond Earth's gravity.
For this, we designed an entirely new rocket.
The Space Launch System. SLS will be the most powerful rocket ever developed.
And with components in production
and more in testing,
this system is capable of being the catalyst for deep space missions.
We need a capsule
that can support humans from launch
through deep space and return safely back to Earth.
For this, we've built Orion.
This is NASA's next-generation human space capsule.
Using data from lunar orbiters that continue to reveal the moon's hazards and resources.
We're currently developing an entirely new approach to landing and operating on the moon.
Using our commercial partners to deliver science instruments and robotics to the surface, we are paving the way for human missions in 2024.
Our charge is to go quickly and to stay, to press our collective efforts forward with a fervor that will see us return to the moon in a manner that is wholly different than 50 years ago.
We want lunar landers that are reusable,
that can land anywhere on the lunar surface.
The simplest way to do so is to give them a platform in orbit around the moon from which to transition.
An orbiting platform to host deep space experiments and be a waypoint for human capsules. We call this lunar outpost Gateway.
The beauty of the Gateway is that it can be moved between orbits.
It will balance between the Earth and Moon's gravity.
In a position that is ideal for launching even deeper space missions.
In 2009, we learned that the moon contains millions of tons of water ice.
This ice can be extracted and purified for water. It can be separated in oxygen for breathing or hydrogen for rocket fuel.
The moon is quite uniquely suited
to prepare us and propel us to Mars and beyond.
This is what we are building.
This is what we're training for.
This we can replicate throughout the solar system.
This is the next chapter of human space exploration.
Humans are the most fragile element of this entire endeavor, and yet we go for humanity. We go to the moon and on to Mars to seek knowledge and understanding and to share it with all. We go knowing our efforts will create opportunities that cannot be foreseen. We go because we are destined to explore and see it with our own eyes. We turn towards the moon now, not as a conclusion, but as preparation, as a checkpoint toward all that lies beyond. Our greatest adventures remain ahead of us. We are going.
We're going.
We are going.
We are going.
We're going.
Awesome, thank you. All right, I'll let you pick the gentleman here in the front.
You mentioned the far side of Mars. Now, did you mean that literally? Because I thought also Mars was visible. Also, parts of Mars were visible from Earth.
Yeah. So, you know, we've landed on Mars 8 times. Every time it requires, you know, communications relays and things like that. So when you land on the far side of the moon, I talked to. Look, landing on the far side of the moon is not easy, but what does it require? It requires a communications relay. We could do that. We just haven't made those investments at this point. What I was doing there was kind of making a point that ultimately we're not falling behind at all. We have every bit of the capability necessary. If we wanted to land on the far side of the moon, we could do it. And I think we'll have that ability to do it with humans, as a matter of fact, when we get the Gateway underway. Thank you for the question.
We have another here. So in the House Science and Space and Technology Committee meeting, subcommittee meeting in March 13th, Representative Waltz asked a question of Peggy Whitson. Did she think that we should have more commercial inputs into the planning for how we get to the moon, what we do to on the moon, basically? And she thought that would be a good idea. Do you see any opportunities for getting more of the small emerging commercial space sector really involved in that planning up front rather than waiting till there's a plan and then how can they help execute that plan?
Yeah, absolutely. And when you look at a couple of things, that's how we're doing the CLIPS program, the Commercial Lunar Payload Services, small payloads to the surface of the moon. We are not telling anybody how to do it. We're saying we have a requirement to get this science payload to this location, who can deliver it, and we're not we're interested in how they're doing it, but we're letting them figure out how to do it. And I think that's a big difference between the traditional way NASA has done business and the new way of doing business. It's also true that if you look at the lander, we talk about going from the gateway down to the surface of the moon and back to the gateway. There's a lot of different ways to do that. Some providers would say you need a transfer element to get to low lunar orbit, then you need a descent module, then you need an ascent module. Other providers say, actually, no, we can go direct to the surface and then direct back to gateway. So, again, we are not prescribing how to do it. We want to make sure that if we're going to help you develop this capability, we want to make sure that it's doable. So our engineers and our technicians will be embedded in the process. But at the end of the day, we're letting people create their own designs so that we can take advantage of it. The other thing is, again, we want them to put their own skin in the game. We want their own investment to be involved because at the end of the day, we want to be a customer, one customer of many. One of the things I think that might help you understand how we're having this change of philosophy is that if you look at the entire architecture with Gateway, it's open architecture. So the way we do data and communications and avionics and docking and life support, all of these things are going to be available to the public online. So if you operate a small company or if you're the leader of a small country, you have the opportunity to build your own lander, build your own tug, build your own transfer vehicle. Any part you want to plug into, it's available and you can do it. Now, we can't create a traffic jam at the gateway, so there's going to have to be rules. But at the end of the day, the goal is for it to be an open architecture so we can get more activity and more support than we've ever been able to get before. So the answer is, not only are we looking for their input, we're going to open it up to them so they can do all kinds of things as long as they're being safe. We're going to open it up to them to participate in all kinds of ways that have never been done before.
I got to give the guys. Thank you, sir. The whole vision of return to the moon to stay, I haven't heard a lot of elaboration about the latter part, to stay. At this point, I'm not sure if it would be very ambitious to try to have like a permanently manned base, for instance, and I'm not sure we really need one at this point. So what is the National Space Council's thinking right now, what that means to stay?
Good question. So right now the goal is speed. So we want to get the first woman and the next man to the moon in 2024, basically within 5 years, which I think is, that's fast, but it's doable. That's the goal, speed. We want sustainability by 2028. So think of it as two phases. The first phase is getting there, making sure that we're retiring the political risk as soon as possible. Second phase is developing the sustainable architecture that would include utilization of the gateway in new and unique ways with international partners and with commercial partners. And by the way, commercial partners will be there from the beginning because that's the only way we can achieve the end state we're trying to achieve. But it's also important when you think about sustainability. When we get there, it's not going to be a permanent presence of humans on the surface of the moon from 2024 onward. That's not what we're talking about. We're talking about a permanent human access to any part of the moon anytime we want. But that is different than a permanent presence on the surface of the moon. It's important to note that we're also going to have continual presence on the moon with landers and rovers and robots. And a lot of those missions will be controlled from the gateway. So presence on the moon, presence around the moon, access to any part of the moon at any time, all of that is what we mean by the words sustainable. Now, do we want to have a moon base where we have a permanent human presence on the moon? Absolutely. Are we going to get that done by 2028? Probably not. But we got to get the first elements done here, then we can talk about how we build that base on the moon. Yeah.
Through the CLIPS program, are there opportunities or fundings in place to allow universities to send payloads, experiments, or anything to train new engineers?
Yes. So right now we've got payloads that are NASA payloads, scientific payloads going to the surface of the moon. But yes, we want to open it up to other payloads that would be university principal investigator kind of driven opportunities on the surface of the moon. So we're not there yet, but absolutely that's on the agenda. Then it can be NASA benefiting from universities or private institutions doing their research, and then the partnership can grow where we could put maybe our payload on with somebody else's payload and share the costs. I mean, the goal here is to spread the costs. So many questions.
Thanks. TJ Cooney from I Need More Space. Question about the lander. The initial ask for the lander, is there a minimum crew requirement that NASA is instituting, 2, 3, 4? And also, what is the minimum amount of time on this initial lander you're hoping to stay on the surface?
So, number one, we're not defining that at this point. We believe that there are going to be a number of different companies that propose a number of different options, all of which would be unique that we will be able to select from. So some solutions might have 2, some might have 4. We haven't said what it's going to be yet. Here's the thing. If we believe we can get an accelerated schedule by steering people to a 2-person lander, we will probably do that. Not guaranteed, but we will probably. The goal is to land the next man and the first woman on the south pole of the moon in 2024. That's the highest priority. So anything we can do to achieve that, we want to make happen. So that was your first question. What was your second question?
Duration on the surface.
Oh, the duration on the surface. So initially when we get there, we're talking about a matter of hours. We're proving a capability, proving a technology. To be clear, we're going to be on the South Pole, which is a milestone in itself in human history. There's a lot of work to do on the South Pole to get a really good understanding of the regolith and the ice and how it's mixed and what else is there. So in a matter of hours on the South Pole of the moon, there will be plenty of very meaningful work to get done and then get back to the gateway. But the first mission is not, the goal is, again, we're not trying to set up a camp on the South Pole of the moon. We're trying to prove that we can get there, that we can do meaningful work, and we can get back.
After 2024 or 28, what do you see the pathway, architecture, and timing to put humans on the surface of Mars? Are there any plans for that already?
So there's a lot of different ideas on that, and I'm sure for every person in this room there's probably a different idea. Here's what we know. We know we're going to need some kind of orbital platform around Mars, and we're going to need, of course, a very unique landing system for Mars. The moon and Mars are very different because Mars has an atmosphere, so we have to have an entry, descent, and landing system that is specifically unique. But as much as possible, we want the architecture at the moon to be replicable at Mars. So what we're learning with the moon, we're learning how to operate that orbital platform, gateway. We're also learning how to do an ascent vehicle. There's no reason an ascent vehicle on Mars has to be different than an ascent vehicle on the moon. But as far as the entry, descent, and landing, that's going to be a unique capability. And then, of course, the other big challenge is when you're in deep space for months and months at a time to get to Mars, what does it do to the human condition? The radiation of deep space, being in a microgravity environment for that long, are all of the effects on human physiology from microgravity, are they reversed when you're in a gravity well that's 1/3 that of Earth, namely Mars? So these are all things that we need to learn on the moon. So when we talk about going to Mars, there's a lot of trade space there, I would say. But certainly it's something we're thinking about, and to the extent that we're developing the architecture at the moon, we want as much of it as possible to be replicable at Mars.
Gary Barnhart, Extraordinary Innovative Space Partnerships, Inc. You speak about going forward to the moon, making it sustainable, partnership with commercial industry, with universities, perhaps even nonprofit organizations. But in order to realize that vision, you have to be able to provide for the infrastructure and the utilities, the power, the communications, the data, the navigation. Is NASA prepared to step up and help orchestrate making that real?
Absolutely. You can't do it without that. So the answer is yes. you know, there's a lot of different programs that NASA has had on its drawing board for many years that require infrastructure, as you've identified. And I think there's a lot of ways we can tie those programs into this particular program. So the answer is yes.
The challenge is in that orchestration. I've been mixed up in earnest since 1982 in trying to make that real. And it is profoundly challenging to, you know, in a sense, re-architect how the agency does business.
Yeah, believe me, I'm learning that.
Question over here.
Did I just say that out loud?
Once we land on Mars, so to speak, do you believe that we will be able to sustain life and women could potentially birth on Mars?
Oh my goodness. I don't think we're going to be, I don't know that that's on the agenda to procreate on Mars. But, you know, again, if you're going to establish a colony, and I'm not talking in the mid-2030s here, but eventually there's going to have to be an ability to sustain life for long periods of time on Mars. So, yes, that sounds very science fiction. It might be 50 or 100 years away, but certainly it's something to consider and think about.
What is the plan to deal with the resource rush that there might be at the South Pole in terms of the peaks of eternal light and the water and other resources that we might find there? Are we going to be cooperating with the Chinese, competing?
It's a great question, and I don't have a crystal ball. I can tell you this. The Outer Space Treaty is very clear that you cannot appropriate the moon for national sovereignty. That is very clear. But what does that mean? That means that China can't own the moon, the United States of America can't own the moon. According to the 1967 Outer Space Treaty, you cannot appropriate the moon for national sovereignty. Now, that being said, when I was in the House of Representatives, we did the Commercial Space Launch Competitiveness Act. And in that bill, I and others thought it was important to define property rights from the perspective of resources. If you attach your labor and your investment to extracting resources from the moon, you, as a private individual, as a private company, as a private nonprofit, whatever it is, you have the rights to those resources. That does not mean that the moon has been appropriated for national sovereignty, but you would have the rights to the resources you extract. So we clearly defined that in the law. Basically, we used the law to define the Outer Space Treaty for the United States, to interpret the Outer Space Treaty for the United States of America. That bill, by the way, passed the entire House of Representatives in a bipartisan way. It passed the entire Senate in a bipartisan way, and it went to President Obama's desk for signature, and he signed it. So this is a... This is, I think, a strong bipartisan consensus that the resources of the moon can be utilized by humanity, but there is also still very strong consensus that you cannot appropriate the moon for national sovereignty as is required in the Outer Space Treaty. So I will tell you, as a Navy pilot, we have a lot of experience flying in international airspace over international waters, and we have rules about doing that. The rules follow the rules that come from ICAO, the International Civil Aviation Organization, and those rules require us to operate what we call due regard. So if somebody challenges me and says that I'm doing something inappropriate, I say I'm a sovereign United States aircraft operating due regard in international airspace. And at that point, what that means is I'm not messing with you, you're not messing with me, we stay out of each other's way, and we're able to operate due regard. When we go to the moon to extract resources, I think those principles probably should apply. There is no regulation on this, there is no law on this, but I think that it's probably appropriate for us to start thinking about it. And if this group, this very impressive group, wants to start, contemplating how we might operate due regard on the moon, that would be, I think, appropriate. The due regard principle, I mean, I've talked to a number of private companies who want to land on the moon, and I've encouraged some of them to name their lander due regard for this purpose. So anyway, that's a good question. It's something we need to be thinking about.
This is about the little details. In regards to the infrastructure of the gateway, are inflatables under consideration for part of that assembly?
So, we have had a number of different companies propose solutions, and a lot of that's proprietary, so I don't want to get into who proposed what. But I'll just say this. If it's a good solution, we will look at it, consider it, and make a decision. And there are good solutions out there that include inflatables and that don't include inflatables.
Jim, in respect of your time, we're going to have one more question.
Okay.
And I would like to request Gerard O'Neill, Voyager Circle, to take the stage and do a photo op with you.
Yes. Can we do the question first? And then...
Yeah, we'll do the question
okay.
while you want to get him up? All right.
Jim, the name is Madhu Thangavelu from USC.
Hi there.
Greg's colleague. It was wonderful to have you here and hear it from the boss. So now, Dave and I, we have been writing books about the moon for a long time and would love for you to have, not a very recent copy,
okay,
but it still says a lot of things you did and are doing. And we'd love for you to have this and use it as a guide.
Awesome.
For whatever it is worth.
Awesome.
Okay? Great. Thank you.
I will use it as a guide indeed. Thank you so much.
Thank you so much for talking.
So before I bring up the Voyager Circle, I want to close with a kind of a final thought, if that's okay, because the folks in this room are very involved in the space industry, and everybody has a very important role to play. I want to put together some thoughts that you can take forward and communicate to the world at large. A lot of times people ask me, why are we spending money on space exploration anyway? I hear that a lot from people who are skeptics about what we're trying to achieve. I want to give you some thoughts about the value of space exploration going back to the Apollo program. I know we're streaming this, I think, online right now. There's some people that are watching this online who get their internet broadband from space. Space communications are a critical capability for humanity, and if you come from Oklahoma, as I do, if you come from rural Oklahoma, internet broadband from space is probably the only internet broadband you might have access to. But it's not just internet broadband. Some people have DirecTV or Dish Network or XM radio. All of these space-based communication capabilities were born from this little agency that we call NASA. And, by the way, its predecessors to NASA, because NASA was only created in 1958. We're a very young agency when you think about it. The other important thing to mention is it's not just communications, it's navigation. People here understand GPS and how it works. This is a technology that was mastered, again, by this little agency called NASA. The way we communicate, the way we navigate, the way we produce food. We are sensing the Earth right now in every part of the electromagnetic spectrum. And from that, we are proving, in fact, I know there's people here from California, we are proving with a partnership with the University of California Cooperative Extension that we can increase crop yields while decreasing water use by 25%, critically important in California, and preserving the nitrates in the soil. So the way and by the way, we are just getting started on this. We are going to be increasing crop yields all around the world, feeding more of the world than ever before because of this little agency called NASA. The way we communicate, the way we navigate, the way we produce food. I come from Oklahoma. The way we produce energy cleanly. We are able to very quickly and rapidly identify methane gas that is coming out of the earth. The energy companies love this. Why? Because then they don't get fined. If we can identify it for them early, fix their problem, then they're not going to be fined by any other government regulator. The way we produce energy, The way we understand weather, critically important. A lot of people don't realize NASA builds all of the weather satellites for NOAA and the National Weather Service. All of the tools that we have to understand where that thunderstorm is going to be, where that tornado is going to be, driven by this little agency called NASA. The way we understand climate and how it is changing is because of NASA. We think about, in this country, how we do disaster relief for people all over the world, capabilities developed by NASA. The way we do national security and defense, in some cases, NASA provides capabilities that defense can use, and they have. Most of the time, defense creates capabilities that NASA takes advantage of, namely maybe some ICBMs that launched Alan Shepard, for example. But the bottom line is this. This little agency that has less than 0.5% of the federal budget, and at its peak for a very short period of time had as much as 4% of the federal budget, this little agency has transformed the human condition. It has elevated the human condition in ways that are not measurable. The return on investment that the American taxpayer gets for what it puts into NASA is huge. It is immense. And when we think about Artemis and the generation 30 years from now, 60 years from now, 90 years from now, what they are going to receive from our generation, the Artemis generation, we don't even know right now the benefits they're going to get from the Artemis generation. But I'll tell you this, what we're receiving right now because of the Apollo generation is magnificent. And they will receive the same benefits from our investment today. And friends, it's not just about Tang and Velcro. It's so much more than that. So make sure you're getting these messages out. Thank you all for having me. Let's get the Voyager group up here, the Voyager Circle.
Here's a gift from India from our friend Avanish.
Oh, thank you.
It's a large chapter.
Thank you, Jim. I'm Alice Hoffman, a director and past president of the National Space Society, and it's my honor to welcome to the stage our donors. And this is the Gerard O'Neill Voyagers Circle. We'll be taking a quick photo with Jim, and then I'll tell you a little bit about the circle and why you might want to be a part of it too. Is everybody up? Okay.
Where shall I stand?
In the middle.
Okay.
We need to get you. Let's fit you in right here. You're very next to Administrator Bridenstine. Okay?
Hi.
Okay. Camera in the back. I hope someone's taking a picture.
Where's our photographer?
Who's the official photographer, Alice?
I don't know. I wasn't.
I hope there was one.
That guy, we're getting his camera.
All right. Let us know when you've got it, please. Mr. Bridenstine has to leave soon.
Okay, Liz, thank you.
Thank you.
Administrator Bridenstine, have a chair.